Welcome to Ask and Learn.
All right, so let's take a look at some electron configurations and see whether they're correct or whether they violate some of the rules. Remember, there are three main rules for electron configuration. There's the Aufbau principle that says we have to fill up lower levels before we move on to the next level. So like the 1s has to be filled before we move into the 2s, and the 2s has to be filled before we move into the 2p. There is Hund's rule that says if we have orbitals, they have to be singly occupied in the same direction before they're doubly occupied. And then we have the Pauli exclusion principle, which says that electrons in the same suborbital, so in the same little room here, have to have an opposite spin. So let's take a look at the first configuration. The 1s is good, the 2s is good. Let's look at the 2p. So remember, Hund's rule says that we have to fill in each of our suborbitals. And remember, the 2p has 3 suborbitals. So each of those 3 has to be filled before we double up electrons. So this first one violates Hund's rule. The second one, Aufbau principle, is good. We're building from the bottom up. Hund's rule is good. You can see how each of the electrons is facing the same direction and they are each in separate suborbitals. And the Pauli exclusion principle is also good here because we don't have electrons of opposite spin when we have these 3. So this is a correct configuration. When we look at C, 1s and 2s are good, but now you can see that this one electron here should be over in this empty space. Hund's rule says that we have to have each of these in separate suborbitals. So this one violates Hund's rule. And I don't know how far they wanted to go with this, but if this were correct, which it's not, but if it were correct that we could put 2 here, these 2 are supposed to have opposite spin. The electron should be pointed down. So technically this also violates the Pauli exclusion principle. And then the final one down here, we have 3 separate. Separate's good in terms of Hund's rule, but this last one should be pointing in the same direction as the first 2. So this one violates the Pauli exclusion principle. So out of the 4, there's only 1 that's correct.